Okay, question 5 is about apples having a normal distribution. Okay, and we've got a mu, mean, and we've got a standard deviation, which is, and these refer to the population, read it carefully. Okay, these are records shows, so that's a mu, not an x bar, that's a sigma. Not an S, and we've got to determine the mean of a sample of 10. So we had earlier in this paper, we had the normal distribution question, which was just about the normal distribution. Here we've got the distribution of x bar. So yes, I'm going to be doing, in my diagram, I'm going to have my mid value is going to be 1.16. Okay, when I come to use the Z formula, because it's going to be an x bar I'm using, I need to be using the x bar version of the Z formula, so I'm going to be dividing by sigma over root n, because I'm dealing with a question about the mean weight of a sample. Okay, so if I wanted the probability of an individual bag of apple being more than 1.25 kilograms, then I would still use this mean, I'll still use this sigma, but I would have just a sigma on the bottom. I wouldn't have the x bar version of the Z formula. So that's why this isn't a plain Z. It's an x bar version of Z, and we want to be above 1.25. So on your diagram, you'll have this bit shaded, and you'll standardize your 1.25 and get a Z value, and then you'll work out the probability of being between that Z value and a high value of 9999 or some such. And then we'll explain the importance of the assumption, okay, which was an assumption about the distribution of weights of bags of apples, okay. Now it says an assumption was made, okay, and it wasn't maybe as clear as it should have been that there was an assumption going on. It's this bit here about records showing the weight of such bags of apples that can be modelled by a normal distribution. So we're assuming there was a normal distribution of the parent population. It's kind of stated in the question, so you wouldn't normally use that as an assumption. But that's what we're assuming. Well, that is what we're taking the distribution to be. Okay, so is that a necessary assumption or not? Do I need to know the parent distribution of individual apples if I'm going to use this Z process for x bar? Well, this comes down to the central limit theorem. Okay, so because our sample size is only 10, okay, then we do need the assumption. It is an important assumption, because if the parent population were not normally distributed, we wouldn't be allowed to use a normal distribution. We wouldn't be allowed to use a Z method for x bar, because n is small. Whereas if n had been more than 30, it wouldn't have been essential to assume a normal distribution for individual apples. Okay, comment on the validity of this assumption. Well, weights of bags of apples is the kind of thing that would have a normal distribution, and the question itself justifies it by saying that in the past records show that the weights of apples may have a normal distribution. So it seems reasonable, and it's supported by our historical experience. Okay, and why might the greengrocer care about this? Okay, well, if people are buying bags of apples, the greengrocers may be interested in the behaviour of people, what weight of apples they tend to put in bags. The mark scheme gives a little bit of a waffly answer to that part of the question. So, okay, a greengrocer may wish to sample apples from large bags in order to assess their weight and quality. I'm not really convinced how well linked that is to the rest of the question. So what they're saying is any reasonable contextual argument and any reasonable application. But if I were you, I'd try and actually talk about the things you've worked out and discussed before in the question, rather than go off on a tangent a bit like this. Okay. Okay, notice on B2, this is what we said, that it's likely to be a valid assumption because we've got that past experience to go by. But because that was historical data, you can always say that this year actually there may be a difference. In the weights of apples may have a completely different pattern than it has in the past. There may have been something that's happened this year. So as always, you can, well, not always, but you can very often argue things in either direction and still get credit, which is good news.